Hello everyone, I'm Galgamuge Fernando presenting to you my final year project ImmunoPass, a decentralized multi-validator immunization passport maintenance verification system. It uses a novel approach in maintaining, validating, and verifying vaccination records using blockchain. First, we will talk about the problems and limitations in the existing vaccination maintenance systems. As one of the main problems, we can identify that the traditional usage of paper-based record keeping of vaccination data is very unreliable. Also, people can forge fraudulent vaccination certificates to bypass travel restrictions or get access to any restricted events. Also, there are cases of bribing of system administrators in the case of digital cloud-based vaccination recording systems, or even in the paper-based systems, people can bribe admins to destroy or change any data the records. Furthermore, it would also be better to have a transparency to the patient's vaccination data for the patient so that they can know how it is used and can be and how it can be accessed. Now I will discuss about different approaches and gaps found out in existing researches and applications on vaccination maintenance and multi-validator systems. Detailed analysis have been done in the literature review. Initially, I will talk about the traditional web-based approach. There were few researches and applications done in the approach of web-based. A summary of strengths and limitations have been stated on the web-based approach. So, the strength of this kind of approach is there will be no transaction fee each time you insert update data in the system in comparison to a blockchain which requires a gas fee to do transactions. Next, as the system is a traditional web-based one, the people will not need any additional knowledge in how to use the application with normal credentials like username and password instead of maintaining wallets as in blockchain. And talking about the credentials, if they get lost, there's no possibility in recovering in a blockchain, but in the web-based approach, the strength is that it could be recovered by means of emails or mobile numbers. Also, if enough, also the web-based approach can be much faster if enough resources are present to run the system. It could be relatively faster than a blockchain. And on the other hand, if we talk about the limitations, we can see that the web-based approach systems are centralized. That means it is controlled by a person or an organization. Therefore, these people can get bribed to manipulate data or could also be destroyed and lost in most of the cases. So these people will have the authority over the data, patient's data, and they can change or knowingly or unknowingly both. And these systems are also prone to cyber attacks as they have a limited number of system resources on which the application is running on. Next, we will talk about the decentralized approach, which includes both public and private blockchains and IPFS. It's an interplanetary file system, a decentralized file storage system. So there have been some researches done on the past 4 years in this area, and the summary of strengths and limitations of those researches are discussed below. So we get decentralized systems such as blockchain. The data in it is immutable, and also in the case of public blockchains, the data transparency can be an advantage to the users, but this can also be a limitation as well in the case of storing any private data. So, and decentralized, and in addition, public blockchains are not owned by anyone, so anyone can access it. No, anyone can view no need special access or credentials. And also, since it's decentralized, it's less prone to cyber attacks because it's readily available in each node. And if we talk about the limitations, it is if in case we lost access to our wallets, which we used to log into the system, it is not recoverable uh, unless or otherwise there's a separate way within the system to recover it. The public blockchains can also be an issue when transferring confidential data, as discussed earlier. So, in case very private data is present, it might not be a suitable way. Instead, using a private blockchain works. And also, it has a gas fee, and whatever transaction we do in the blockchain, there's a fee that will be charged. And also, this speed transaction speed within the blockchain can vary from blockchain to blockchain. So both this gas fee and transaction fee can depend change on the blockchain that is being used. So, and also if we are using private blockchains, still it will be governed by another organization or a party, and the reliability of and security of these private blockchains are questionable. And next, I also have found a machine learning based approach. Using a machine learning approach could be a strength because there will be less human interaction while processing this data, so it will be less prone to errors. So, but on the other hand, there could also be limitations in case the data being input to the machine learning model could be not accurate data, as well as the output data from the machine learning model could also later be manipulated if needed to. Another approach is also using NFCs, the near field communication based approach. So in this case, it has the ability of identifying a person uniquely using these NFC tags or devices, as well as it's portable. But on the other hand, these devices, since they are physical, they could be forged or duplicated, stolen, or destroyed. Next, we also have biometric based. So biometrics helps to identify each user within the system uniquely. So therefore, we know who is logging, and only that person can have access. But even in the biometrics, if these data are stored in centralized or traditional database systems, this biometrical data also could be interchanged or deleted by any admins, or if any hacker get access to it. So this diagram shown is the concept map, which has a summary of the researches done and discussed before, and any identified gaps, which also shows any identified gaps and also gives an overview of the identified solution. The areas marked in green will be the areas that will be attended to in this project. So I have selected on using a public blockchain, as any person should be able to verify vaccination in the system, since any person can hold a vaccination card. It's not limited to a certain group of people. As well as I will be focusing on the areas of areas of data ownership, accuracy and integrity, and data accessibility in the parts of my research, as to keep the scope to a minimum. And to apply this focus areas, I have selected the healthcare domain, and as it is a vast area, I have selected the subdomain vaccinations healthcare domain. uh, as the evaluation, Since we are using a blockchain, we should focus on the cost, which is the gas fee and the efficiency of the system, and also the validity of data, which I will be focusing on this project. So considering all of the above points and aspects, I have decided in using the Solana blockchain out of selected blockchains, since it is very efficient due to high transaction speeds and the low costs of transaction and the support available in the internet. So taking the concept map into consideration, the final solution is to implement a scalable multi-validator system. The different authorized entities can vote on another entity within the same system. The capability of data immutability and transparency. Now let's go forward for the demonstration of the project. The code. Now I will be explaining the core code of my project. The core is implemented in the Solana blockchain using the Anchor framework. The programming language used is Rust. The core is written in a single file known as a Solana program, is also similar to smart contract. First, I will talk about the main entities in the Solana program. There are 5 entities in the Solana program, which are doctor, passport holder, vaccination camp, which are the users, and then we have the vaccination record, vaccine and validation record entities. Entities are known as accounts in the Solana blockchain, and we could have used one big account to hold all of these records, but this will not be a very scalable, and the cost for storage within the blockchain will be high as we allocate a fixed size for the whole storage. Even we use the whole storage or not, we'll have to pay the full amount. Therefore, I have broken down each entity into separate accounts of their own, so that the payments for the account storage will be made on demand by the author who creates that account. So since each account will require only a small amount of space, the storage will be more affordable and will scale to an unlimited amount of accounts and users. Also, each account will have their own public key and author. And also, I have added an additional owner field in the user types entities so that we can map any users to the wallet address that they are using so that we can identify them easily. Next, there's a concept called rent, which is like once an account is created, we have to put money into it. So the blockchain will collect a small amount of money from this accounts as rent. So when we create each and every entity, they have to pay a rent to exist in the blockchain. And this rent is proportional to the size of the account. If the account runs out of money, the account is deleted and the data is also lost. This also doesn't this doesn't mean that we have to pay for the accounts always. There's another method known as the rent exempt, where the rent will not get collected from the account. This is done by adding money to your account enough to pay for 2 years of rent. Once we do that, the money will stay in that account forever and not be used. And if we ever decide to close the account, we can get that money back, what we have put into the account. So therefore, for the calculation of storage space, for each account is calculated and set so that we know there is a fixed rent on that account. Doing this, it will make it more scalable and cost efficient. So I have defined here different attribute by storage size in bytes for each and every attribute that will be stored in each account. Lastly, using the defined sizes, the total size of each and every account is determined here. So for example, the doctor uses for 5,761 bytes and the vaccination camp 5,337. For this defined size, we can also calculate the rent and the rent exempt. For example, if we want to calculate the rent of this doctor, we can calculate it by entering the command Solana rent 5,761, and we can see here rent per byte per year is this much, and minimum rent exempt is this much of Solana, which is the native currency of the Solana blockchain. Now we will talk about the different functions of the Solana program. So there are several built-in functions as well for querying data. And if I get the core main functions that I have used, there's a function to create a doctor. There's a function to create a vaccination camp. There's a function to create a passport holder, and these create functions can be also used to update the account itself as well. Then we have a function to create vaccination records. And next, we also have function to create validation records for a vaccination record. As of now, the system only enables to validate vaccination records, but it could be scalable to validate any entity within the system. All validations for the attributes are done in below. For each and every attribute, there are validation checks that I have implemented as well. Next, let's move on to the demonstration of the application. This is the ImmunoPass web application. As we can see in the dashboard, in the landing page, we can see the 3 types of user login page: passport holder, doctor, vaccination, and another button for verify vaccination page. First, we should connect our wallet, and then we should, for example, let's go to the passport holder. We don't have an existing account. We can go to here and connect the wallet. Since I have already have an account, it says the user already exists. If I go back and try to log in, it will show my details, the vaccination passport holder details, as well as the activeness of the account and how many vaccinations we have taken. And if we see below, we can see what vaccination they have taken, and in this case, we can validate it or quit or reject it. And we can, if we view here, we can see who have validated or rejected our records. Since there's none, it won't show anything. Now going back, let's see the doctor login. So once we log in as a doctor, it shows the doctor details and it shows all the vaccination that he has done. So if we see here, we have approved this vaccination, and if you view this record, it shows that for the relevant passport holder have validated the account. If we see another vaccination, for example, this shows that the vaccination camp has rejected it, and later the doctor has approved, and again the vaccination camp has approved it. And also the doctor has next, let's see the vaccination camp. It is also very similar to passport holder. Now if we log in, it shows the details of the vaccination camp and the activeness of it and the number of vaccinations it has done to now. So it will show these all the vaccinations they have done, as well as the relevant entities who has validated or rejected it. Next, let's let's verify an existing vaccination. So anyone can connect their wallet and log into this dashboard. They do not need any special accounts or anything. So in here they can search by the batch number of the vaccination and load the relevant vaccination. Then it will show all the vaccination information, the date of vaccination, the vaccine, the batch number, which is this one, dosage, status, notes, age and weight. And it will also display the patient information, then also the doctor information, then information of the vaccination camp. And going below, it will show all the timeline of the approvals and rejections of this vaccination. So initially, the passport holder has approved. Next, the doctor has approved. Then is rejected by the vaccination camp. Then again, the doctor has approved it, and again, the passport holder has set it to pending. Next, let's initiate a new vaccination for the patient, passport holder above. So if we log into the doctor dashboard, there's a section called actions where it shows all the doctor actions. For now, it shows the initiate. Now, if we go to the initiate vaccination, we can enter the patient's ID, load the patient, and the patient is loaded now. Next, we can select the vaccination camp, like we are taking the vaccine from. We can load the vaccination camp. Now, see, it has been loaded. Next, we can enter the vaccine. For example, Pfizer. Batch number, let's put P100. Dosage 50 milligrams, age 24, weight. And let's keep this as blank since it's optional. Next, we can initiate the vaccination. As you can see here, the wallet pops up asking to do the transaction or not. We can approve the transaction or cancel it. Once we approve it, it will show the success message, and then we can go. Now the vaccination has already been created. If we go back, the patient's login. Now we can see a new vaccination has been added in the Pfizer section, and it is the date is today's date. And if you view the record, no validators yet. And this is also shown in the doctor dashboard as well. Here on, and it is also not approved yet. As well as we can go back to the vaccination camp. Here also it is shown. Here it's shown as well. Next, let's go to the doctor dashboard and approve that vaccination. Can select approved. Then we can give a message and save it. And again, the wallet will pop up asking us to approve the vaccination. We can approve it, and the pop-up will come. We have successfully changed the status. Now, if we view that record, it will show that the doctor has approved it. Next, going back to the patient, we can also see that from their side also the doctor has approved the vaccination. If the patient wish to reject it, they could reject it as well. If we see here, it's approved, so the patient wish to reject it, he can reject and enter page if you and save it. And then we can approve the vaccination from the wallet through the transaction. Now it will give a pop-up saying it's success. Next, we can go to the verify vaccination and enter that batch ID, load the vaccination, and from here it will load the vaccination data, patient information, doctor information, vaccination camp information. And if we go below, it will show in the order who approved the vaccination and who rejected the vaccination, along with the message they have provided to see why they have approved it or rejected. Next, I will be talking about the evaluation process. I have done my self-evaluation, which confirms that I have covered 85% of my functional requirements and 100% of my non-functional requirements. I have also used external evaluators, which includes 3 blockchain experts, 1 healthcare domain expert, and the end users, which is the general public users that will be using the system. I have done both qualitative and quantitative evaluation on my project, which will be discussed in the coming slides. If we talk about the qualitative evaluation, the below mentioned evaluation criteria is used to evaluate the project, which are the topic selection and the overall idea, scope of the project, system design and architecture, solution and prototype, and the limitations and future enhancement. And the evaluators of this qualitative evaluation are all the evaluators mentioned before. Next, we talk about the quantitative evaluation. I have carried out a survey with the actual end users on 3 questions. First was asked whether they think this system would be useful for maintaining vaccinations for the public. 75% of the evaluators from the general public has voted yes, and 25% of them were unsure of the usefulness. Next, it was asked whether they would like to use this system in maintaining their vaccination records in the future. So when you look at this, it shows that almost half of the evaluators are unsure about their usage of the system. Also, 58% have voted that they would like to use the system. Lastly, it was asked on a 1 to 5 scale, what is the quality and the usability of the prototype? Almost half of the votes have been on the score of 4, with the second highest on the score of 3. Overall evaluation summary was in how to facilitate new technology like blockchain within the general public users, which can comprise of both technical and non-technical people. Next, I will be talking about the limitations and future enhancements of the project. First, I will be talking about the limitations. One of the most highlighted limitation is the privacy of persons' data within the blockchain. Privacy of passport holders can be compromised. A person can trace a random public key of a user account and hold a record of mappings as the system uses a public blockchain. The data will be viewable by anyone. Since this system doesn't uses non-critical person data, it won't be an issue at the moment. The solution would be to encrypt the data within the blockchain and only decrypt it if requested from the account holder itself. The next limitation is that the system is prone to human errors, as in every system. Since the vaccinations are entered manually and no automated process for scanning or reading any vaccination directly into the system without human interference can cause an issue while entering data. As the last limitation, it could be the disability of tracing a vaccine from its source to its host. We can overcome this by issuing a certificate from the source or the company that is issuing the vaccine that will be help to trace the origin of the vaccination. Next, we will be talking about the feature enhancements. And one effective enhancement could be to incorporate the contact tracing, which can be used to identify disease spread using user devices such as mobile phones or smartwatches in parallel to the location of them. Since and the next enhancements could be use of NFTs. Since the application runs on blockchain, we can incorporate NFTs or non-fungible tokens rewarding system. This can encourage users to take vaccinations legally and legitimately. Also, this can eliminate the maluse of the vaccinations. Also, we could use interplanetary file system or the IPFS to manage vaccination validity certificates for the vaccine. So that could be issued by the company itself that's creating the vaccine. So these can be assigned to a person by the time of vaccination, expelling any manual data entry. And this will also make sure that no vaccines will be ill-used or left out. And thanks for listening to my presentation on my final year project.